So let's check out this integral here. We have a continued fraction, 1 plus x over 1 plus x over 1 plus x. So we want to find the integral, so we have to do some checking first. So if you put x equals 0, then all this part in here is 0, so you have integral of 1 dx. And if you put x equals 1, it turns out that you get the golden ratio. So it's finite at the other limit. So how do we integrate this? It doesn't seem like we can use substitution or integration by parts. So here's the strategy. So we checked it, the limits, and then you can see that if y equals this, that this same pattern repeats within itself. So you have y equals 1 plus x over y. So you have 1 plus x over y. So this is a quadratic equation in y. So we multiply by y both sides of the equation. And then we use the quadratic formula with a equals 1, b equals -1, and c equals -x. So we get this root of the quadratic equation. If you put x equals 0, you get 1 plus 1 divided by 2, so y equals 1. So that's a check that this formula is working out. And then if you put x equals 1, you get 1 plus 4, which is square root 5, plus 1 over 2, which is the golden ratio. So this function is entirely continuous between 0 and 1, like this function here, you can see it's continuous. So we put it in the function. Now we just have to integrate this. This one is not so bad. This is like integrating square root of x, but there's a u substitution here. And 1 over 2 integral from 0 to 1 is 1/2, because you get x over 2. So the antiderivative is here. So what I did here is I did 1/2 is x over 2. Then I found the function to the 3/2, this part here. So when you differentiate it, you get 2/3 to cancel the 3/2, and 1/4 to cancel the 4, and then there's already a 1/2. So this is the antiderivative, and you just put in 1 and 0 at the other limit, and you get this one. So that's the value of the integral. So I have a challenge problem for you. So instead of in the numerator, the continued fraction, I move the continued fraction to the denominator. So this makes the integration a little bit harder, but if you learned the steps from what I showed you in the first example, you should be able to do this integral too. So thanks for watching, and hit the like and subscribe. I'm trying to start off a new channel here. So thanks, see you in the next one.